What's something people don't know about the double-slit experiment? Most people have heard of it, maybe from a science class or a YouTube video, but the real story behind this experiment is even stranger than you might think. It's not just a quirky physics demo, it's a window into the deepest mysteries of reality, and it's been at the heart of a scientific feud that's lasted for over a century. The double-slit experiment isn't just about light acting weird, it's about the very nature of existence, and it's forced scientists to question what we know about the universe itself. It's not just about light acting weird, it sparked a century-long debate between two of the greatest minds in science. On one side, you had Albert Einstein, the genius who changed our understanding of space and time. On the other, Niels Bohr, the father of quantum mechanics, who believed the universe was far stranger than anyone could imagine. Their arguments weren't just academic, they were passionate, personal, and sometimes even heated. These debates shaped the course of modern physics and set the stage for discoveries that would change the world. And finally, we have an answer. So here's the deal. Back in 1801, Thomas Young's double-slit experiment showed that light behaves like a wave, creating those trippy interference patterns. Imagine shining a beam of light at a barrier with two tiny slits. Instead of just two bright spots on the wall behind, you get a whole series of light and dark bands, an interference pattern. This was proof that light could act like a wave, rippling and overlapping just like water. But that was just the beginning. The experiment was so simple, yet so profound, that it would go on to shake the foundations of physics for centuries to come. Fast forward to the 1920s, and Einstein said, "Wait, light's a particle too. We should be able to catch it acting both ways at once." Einstein's idea was revolutionary. He'd already shown that light could act like a particle, a photon, when he explained the photoelectric effect, which won him the Nobel Prize, but he couldn't accept that light was only a wave or only a particle. He wanted to believe that, with the right experiment, you could see both sides of light's personality at the same time. This idea set off a scientific arms race to design experiments that could finally settle the question, is light a wave, a particle, or something even stranger? Niels Bohr, his quantum rival, wasn't convinced. He argued the uncertainty principle meant you can't know everything about a quantum particle at the same time. Bohr believed that the act of measuring something at the quantum level changes it. If you try to find out which slit a photon or atom goes through, you destroy the interference pattern. In other words, you can't have your cake and eat it too. This was the heart of the uncertainty principle. The more you know about one property, like position, the less you can know about another, like momentum. Bohr's view was radical, but it fit the strange results physicists kept seeing in their labs. For nearly 100 years, no one could settle this epic debate. The world's best minds tried everything, new experiments, new theories, even new ways of thinking about reality itself. Some physicists sided with Einstein, hoping for a hidden explanation that would make the universe less weird. Others joined Bohr, embracing the uncertainty and randomness at the heart of quantum mechanics. The double-slit experiment became a symbol of the quantum mystery, a puzzle that refused to be solved, no matter how hard anyone tried. But now, in 2025, MIT scientists pulled off the ideal double-slit experiment using ultra-cold atoms and laser traps. Their results? This wasn't just another version of the old experiment. By cooling atoms to near absolute zero and using lasers to control their motion with incredible precision, the MIT team created the most perfect double-slit setup ever attempted. They could watch individual atoms as they passed through the slits, and they could even decide whether or not to measure which path the atom took. This level of control was unimaginable just a few decades ago, and it allowed them to test the very heart of the Einstein-Bohr debate. When they checked which path the atom took, the interference pattern vanished. Just like Bohr said. The moment they tried to find out which slit the atom went through, the beautiful pattern of light and dark bands disappeared. Instead, they saw just two blurry spots, as if the atoms had chosen one path or the other, but never both. This was the smoking gun Bohr had predicted all along. The act of measurement changes reality at the quantum level. The universe, it seems, really does play by quantum rules, no matter how much we wish it didn't. Einstein's idea didn't hold up. For decades, Einstein hoped there was some hidden mechanism, some hidden variables, that would explain away the weirdness of quantum mechanics. He famously said, "God does not play dice with the universe." But experiment after experiment, including this latest breakthrough, has shown that the universe really is as strange and unpredictable as Bohr believed. The dream of a neat, orderly clockwork universe has been replaced by a reality that's fundamentally uncertain, where observation itself shapes what's real. This breakthrough seals the deal. You can't have your quantum cake and eat it too. The double-slit experiment, once a simple classroom demonstration, has become the ultimate test of our understanding of reality. Thanks to the work of generations of scientists and the latest advances in technology, we now know that the quantum world is real, and it's here to stay. The universe is stranger than we ever imagined, and every new discovery only deepens the mystery. But that's what makes science so exciting. There's always more to learn, and always another question waiting to be answered. Want more science showdowns and mind-blowing discoveries? Hit that subscribe button and stay curious. The story of the double-slit experiment isn't over. New questions are already emerging, and the next breakthrough could be just around the corner. So keep exploring, keep asking questions, and remember, in the quantum world, nothing is ever quite what it seems.